Hi, good evening, everybody. Uh, Today, this session organized by Electrical, Electronic and Telecommunication Engineering Sectional Committee of IESL is focused on electric vehicle usage and ownership. So the topic is Charge Your EV Like a Pro, and the resource person is Engineer Janaka Wilamadharma, who has been in the electrical vehicle field for more than 10 years now. He himself a EV owner and also an engineer, and he has expertise on both backgrounds and providing very innovative solutions for the EV community with their problems and their questions. So I hope that it will be a very interesting session today with the practical aspects and also some knowledge on this field which is now emerging in the Sri Lankan market also. So to start today's proceedings, so I'd like to invite Engineer Viraj Muthugala, the chairman of Electrical, Electronics and Telecommunication Engineering Sectional Committee, to welcome you all and start the session. Thank you.
Thank you, Engineer Sabun. I think I'm audible, right?
Yes.
Yes, you can audit. Yes, we can hear it.
Right. Thank you. Good evening, everyone. So it is my pleasure as the chairman of Electrical, Electronics and Telecommunication Engineering Sectional Committee to warmly welcome you all to today's webinar related to EV charging, related to the topic Charge Your EV Like a Pro. So this event is organized by the Electrical Sectional Committee of ISL, and we are delighted to see such a strong interest in this important and timely topic. So as our country moves steadily towards the sustainable transportation and cleaner energy solutions, EVs are becoming an increasingly important part of our daily lives. So however, owning an EV is not only about driving electric, it is also about understanding how you charge it efficiently, safely, and intelligently. So today's session, uh, we would like to provide practical knowledge on understanding the fundamentals of EV charging, meeting daily commuting needs efficiently, maintaining better battery health, applying smart charging strategies for optimal performance. So we are indeed privileged to have with us an expert who has been closely involved in EV movement in Sri Lanka. Our resource person this evening is Engineer Janaka Wilamadharma, an early EV adopter and a well-respected professional with extensive international experience. His long-standing contribution in promoting EV mobility and sharing practical knowledge has greatly benefited the engineering community as well as the EV users. I warmly welcome Engineer Janaka and thank you for accepting our invitation to share your expertise with us. And I would like to encourage all the participants to actively engage in this session and the Q&A session after the session. With these words, I would officially welcome Engineer Janaka and wish you all a very informative and engaging session. Thank you. Over to you, Mr. Janaka.
Thank you very much, Miraj and Supun, and thank you all for being with me today evening, and good evening to all of you all. So I will, in the interest of time, quickly jump onto the presentation because we have 1 hour. Probably I will take a little bit more because I have my previous experience. So when you all have questions, things can get dragged on. So let's start the session by understanding what is an electric vehicle. I mean, in colloquial terms, we refer to an EV as a machine with a battery and a motor, but if we consider the different types of electric vehicles, so we have in the first category we have hybrid electric vehicles, and then we have the battery electric vehicles, and this is the category that we refer to as EVs most often. But even the hybrid electric vehicles are considered electric vehicle. And then fuel cell electric vehicles, they also have an electric motor and a battery. Now, all three have the similar characteristics to be called electric vehicle. Now, even electric motorcycles belong to any of these categories, because it can be a battery electric vehicle or it can be a hybrid electric vehicle. So, what's the difference between a hybrid electric vehicle and a battery electric vehicle? Because hybrid electric vehicle has a engine and a fuel tank in addition to the motors and high voltage battery. Battery electric vehicle, you have a plug. Now, the difference between these two is generally hybrid electric vehicles, the battery gets charged when you run the vehicle from the engine or when you apply brakes to regenerative braking. In the battery electric vehicle, you have a plug where you can really connect it to a charging station or the grid and charge. And fuel cell electric vehicles, of course, will have a fuel cell stack and a fuel tank. It will generate electricity, and the electricity will be supplied to the motor, and it will be stored in a battery also as a backup. So all these are electric vehicles technology-wise. Fuel cell electric vehicles are quite unfamiliar to us in Sri Lanka, but in some countries, some of the Asian countries like Korea, they are quite popular as well. Due to the high cost of charging infrastructure or hydrogen fuel stations, we are unlikely to see any fuel cell electric vehicles running on our roads any soon, but it can change. We don't know. Technology changes, the cost of technology changes, so anything can happen. Now, the hybrid electric vehicles, the main concern was that they are mostly running on the engine and the motor and the battery giving additional capability. So they thought, let's add a plug to the hybrid electric vehicle, and we call it a plug-in hybrid electric vehicle. Generally, compared to a normal hybrid electric vehicle, the plug-in hybrid electric vehicle tend to have a slightly larger capacity battery, so that it can be charged either using the engine and the regenerative braking or directly by plugging into a charging station or the grid. Now, the battery electric vehicle, one of the most in the early battery electric vehicles, I would say, people had a concern about range. So they came up with an idea to have a small generator in the vehicle. And so when you want to extend the range, the generator can generate electricity and supply electricity to the motor as well as charge the battery. So we call these extended range battery electric vehicles or a range extended electric vehicle. Now there are some vehicles being marketed in Sri Lanka also as range extended electric vehicles even at this moment. So let's see some examples. Now the most common hybrid electric vehicle we know is the Toyota Prius, because they were the kind of pioneers in the modern hybrid electric world industry. But hybrid electric vehicles, they are even in the 1900s. We are not going to talk about that, but historically, electric vehicles came into being before gasoline engine vehicles. In the early 1900s, there were a lot of electric vehicles running on the roads, not in our country, but in Western world. And then the invention of gasoline vehicles kind of outpaced the electric vehicles because of the range. The same problem we had about 10 years back with electric vehicles. So, of course, the most common battery electric vehicle that we know in Sri Lanka is the Nissan Leaf. And then the Toyota introduced a fuel cell vehicle in the US market. Initially, their take-up rate was high, but then towards 2020, 21, 22, the new car sales of fuel cell electric vehicles, even in the US market, has come down. But it has not affected that much in markets like Korea. So we are not going to go into detail of that because we don't encounter these vehicles in Sri Lanka. And the most popular plug-in hybrid electric vehicle that we had in our country for the past 10 years was the Mitsubishi Outlander plug-in hybrid. Of course, most of the users did not use this as a plug-in hybrid, but a regular hybrid. Only when the fuel crisis came into the country, we saw the Outlanders even stopping at charging stations. And the BMW i3, which is predominantly a battery electric vehicle, some models have a small generator as a range extender, although they don't really market it as extended range BEV. They market it as a hybrid, I think. But the functionally, it is something. It's basically an battery electric vehicle with a small generator. Now, if we consider the latest vehicle imports starting from last year, the most popular hybrid electric vehicle is the Honda Vessel, I think. And then the most popular plug-in hybrid electric vehicle is the BYD C-Line 6. And the most popular battery electric vehicle was BYD Atto 3. And there was a new vehicle introduced as a range extended electric vehicle. It's called Leap Motor C10 SUV. So then, before we talk about charging, I need to make a kind of a sarcastic remark because I know some of you may get angry with me, but it helps me to spread the word because I tell this to everybody when I have a presentation that 99% of the males in Sri Lanka, they think that they are qualified electricians. I mean, that would have been same for me also if I had not learned the finer things about electricity. I hope you will agree. So I will tell you why. When it comes to electric vehicles, you need knowledge more than the capability of changing an electric bulb. You need to understand the electric vehicle, electricity safety. And these are some of the examples that I have gathered from real life scenarios. Now, this particular one on the top left corner, this is a Nissan Leaf EVSC. You might call it a charger, AC charger, but the correct term is EVSC. We will talk about it later. Now, this one comes from when the vehicles come from Japan. It comes with a different plug. This is a US standard plug, which is capable of drawing 20 amperes. Now, this EVSC actually draws 15 amperes, and we don't have a proper socket to plug this. So everybody is trying different methods, and the problems is without understanding the uh, electricity principles behind all these things, people do all various things. And of course, these three photographs that I have made, I mean, just to explain these things, I have purposefully damaged these things to show that they are not capable of carrying high current for a long period of time to be used for electric vehicle charging. Now, on the far right-hand corner, because of non-availability of proper socket to plug this, people have been doing all these things. Now you can see some of the so-called electricians. I have physically seen this thing being done. So that is why I'm being sarcastic and trying to explain. So once you go through the today's session, you will understand how to manage these things properly. So I'll go to the next slide, or rather show you a next zoom vision picture. So they are just using wires on the plugs without buying a proper socket. Now, why the socket has got burned? Again, there are issues like dust and debris being collected on the socket because daily you plug in and out, and then you draw a high current continuously for 5-6 hours. And if there are no proper contacts, they get heated up and then they get burned, and they might even cause fires. So this is an example on the here plug. I just bought a this European type 16 ampere socket on one side and 13 ampere connection on the other side. And I set the current draw on my EVSC to 10 amperes and tested whether the locally purchased 15 ampere to 13 ampere adapters can work. And as you can see, they cannot. After a few hours, they get melted. So you have to be very careful in applying all sorts of sockets and adapters for your electric vehicle charging. So that's the first warning I wanted to give in this discussion. So always try to practice the safe methods, because unlike normal equipment usage, we are using the charging equipment for a longer time, for a couple of hours with continuously high current, and all these loose connections and things like that will have a disastrous effect. Now I will show you why I want to start the lecture from this point. Now these are some of the screenshots that I have captured. So this person has a problem. He doesn't explain the background, but he has a 13 ampere plug, but most likely either the 13 ampere socket has not been wired properly, or he's using a EVSC which draws 15 ampere, but he has a 13 ampere plug here. Most of you might quickly guess why it will happen this way, because simply the specifications don't match. So people respond in the social media. So one person is saying, yeah, 15 ampere plug and the base is the best way to do it. And he knows that these are banned. Now, most of you may know that IESL and PUCSL collectively, they ban use of sale and use of 15 ampere plugs and sockets in 2019. The idea is our national standard should move to the British standard with 13 ampere plugs and sockets, and beyond that, you should use industrial sockets for high current application. So he's giving advice, saying that outstation you can still buy them, so you don't have to worry. And then somebody says replace with a fuse plug, but it's already a fuse plug that has got burned. And same happened to me. 13 ampere fuse burnt after replacing with new one. This happened 4 times. So he's repeating the same mistake 4 times and finally changed the top and plug base is 15 ampere and now works and no heating. And this person, I left the name intact because he's giving the correct advice. Because if the 15 ampere sockets are being phased out, the next step is to go for an industrial socket like this, which are available in 16, 30, 2 ampere ratings. And this person is another one of those 99% males in Sri Lanka I'm talking about. I have been advising him not to do these things and sell these adapters, but he's repeatedly doing. In last February also, he's advertising. Now you can see it has a 20 ampere socket, which is used for this Nissan Leaf EVSCs on one side, and he's wiring a 13 ampere plug on the other side, and he's selling this as an adapter. Now what happens is, the moment you plug this into our wall socket, The car draws 15 amperes because the leaf, Japanese leaf EVSEs allow 15 amperes of current to be drawn into the car. So he's plugging it into a 13 ampere socket, and this is asking for trouble, right? So people don't want to admit that they don't know. So because of that, I thought of starting the discussion on this point, because you need to understand the basics of electricity. Those who know all these things, pardon me, but I am assuming for these will be some refreshing facts for some of the engineers who are here. Now, we use volts for voltage, named after Alessandro Volta. Now, all these units are named after scientists. Because of that, the terminology we use with capital lettering. The units are not simple V, not simple A, but they are capital V, capital A, capital W, and hours, of course, we use simple, and watt hours. Now, watts is volt into ampere. That's the instantaneous power that you can get. Now, if you draw this power over a period of time, they become watt hours. That is energy. We measure energy with watt hours. We measure power with watts. Now, many EV users confuse these two units. They know there's a unit called watt. They know there's a unit called watt hour, but they don't know which one is what. And they apply this interchangeably in EV language. Now, 1000 watt hours is 1 kilowatt hour, which is the basic unit of electricity that we buy from CB or LECO. And I included the term frequency hertz also because named after a scientist, but we will later see what this hertz is if you don't know. So the fundamental things to remember if you want to talk about charging an EV is watts and watt hours. So let's continue. Now, if you take a simple circuit like this, connecting a battery to a bulb, there's a voltage across the battery and there's a current which flows into the bulb, and the current direction is from positive to the bulb and coming back to the negative terminal of the battery. Now we call this a DC circuits, direct current, because the current flows in one direction, direct current. And if we change the polarity of the battery, the voltage appears in the opposite direction and the current also flows in the opposite direction. Now, if there's a mechanism of continuously changing the polarity of the batteries, we have an alternating current circuit because the direction of current flow changes. Now, generally, in this circuit, this is what happens. There's a voltage applied on the positive direction and we change the polarity and the voltage gets applied in the negative direction. And we can repeat the same thing. We call it a square wave. And the time taken to complete one positive cycle and one negative cycle is considered a cycle in the square waveform. Same thing, in reality, we use sinusoidal waveform for our AC supply. So the same concept, there's a cycle and the inverse of the cycle is a frequency. That means number of cycles per second. We measure that in hertz. That is why we say our electricity grid supply is 230 volts and 50 hertz. So we kind of know the V and A relationship, and then it can be applied to AC circuits as well. Then let's talk about the watts. And the watts can be remapped. This formula can be rewritten to make volts ampere into hours is watt hour. That means the energy can be expressed in a DC circuit in volts ampere hours. So that means volt into ampere hours. Let's take a battery. Let's take a normal 12-volt car battery. Usually the manufacturer will specify, oh, this is a 12-volt battery. and it has a capacity of 17 ampere hours. So the 17 ampere hours is the capacity when it is 12 volts. Since all 12-volt batteries are 12 volts, when we want to choose a battery, we use the ampere hours as a gauge of measurement to buy different capacities of batteries. Now, this can be rewritten again with the same formula. And we can finally write it as 12 into 72 watt hours. If you multiply the value, you get some watt hours. Now, if you divide that by 1000, then the normal 12-volt battery capacity can also be expressed in kilowatt hours. Now, in the automobile industry, mostly you use 6-volt battery, 12-volt battery, or 24-volt battery. So when you want to buy a battery, you don't really have to ask for a kilowatt hour so much battery. You know what the voltage is. You ask for a 72, 45, 35 ampere hour battery. Now the same principle applies to lithium-ion batteries used in electric vehicles. Of course, lithium-ion battery cell is very small. The lowest size is this kind of a small cell. It's 3.7 volts, 1000 milliampere hours capacity. So that is the capacity of the cell. You combine thousands of these cells in series parallel arrangement, and you build a electric vehicle battery. Even the earliest Teslas, they use Panasonic, this form factor 1680, 850 form factor, Panasonic lithium-ion cells. They add thousands of lithium-ion cells in a battery pack. So, electric vehicle manufacturers started quoting the power in kilowatt hours. And as the industry progressed, different electric vehicle manufacturers decided on different voltages and cell arrangement for their batteries. That means manufacturer A will have a 400 volt battery, manufacturer B will have a 300 something volt battery, or a hybrid electric vehicle like Toyota Prius will have a 200 volt battery. So expressing battery in ampere hour terms is going to be very confusing when the consumer wants to understand the difference. So all electric vehicle manufacturers quote their battery capacity in kilowatt hours. That means how many units of electricity it can store in the battery. So that is a fundamental that you need to so all of you couldn't hear? Can you all hear? Can you
Yes,
send me a chat?
We can hear you, sir, but your presentation just stopped. Can you reshare it again?
Yes, because can you see the presentation now?
No, not sure.
Not showing.
I think we'll be able to see. Let me check and confirm. Yeah. Full
Is it okay
display.
now?
Okay.
It has gone back.
No.
Okay now. So we were just here. So we were talking about why electric vehicle battery capacities are being expressed in kilowatt hours, because one thing is the value is large. The other thing is the battery voltage can differ from manufacturer to manufacturer. But generally, the cell voltages are same depending on the technology of the battery cell. But manufacturers tend to build battery packs with different series parallel arrangements. So because of that, the capacities differ. Now we just understood what a DC circuit is and what an AC circuit is. So in electric vehicles, majority of the vehicles have two methods of charging. The first one is AC charging, where you can connect the vehicle to the AC grid and directly charge. And second one is you have a DC charging station. Now in the first case, there is a charger inside the car. Now to be able to do AC charging, there is a charger inside the car. Now what you see outside, there's sometimes a brick-like portable device or a wall-mounted device. It is not a charger really. It is a kind of a controller. I will explain that in a minute. So on a DC charging station, the charger is actually outside in this big box that you see at a charging station, and you supply direct current straight to the battery. Of course, there are some controls happening, but you are supplying DC through this cable to the battery. So that is the main difference between the two charging methods, AC charging and DC charging. Of course, AC charging, because we are using our normal grid, it can be slower because it all depends on how much power you can draw from your wall socket. Fast charging, on the other hand, depending on the supply from the grid to the charging station, they can even go up to 150 kilowatts or even more. Now there are talks about 1,000 kilowatt chargers in other countries. Of course, the grid needs to support that kind of power. Now, AC charging generally is done with a device that we colloquially call a charger, but it's not a charger. It's called EVSE. Am I getting chat messages? So what do you mean by no? You cannot hear? Can you all hear?
We can hear you, sir. Only need to share the full screen
Yes,
from
because
bottom.
somebody posted a message saying no. Okay. Is it okay now?
Okay, perfect.
Okay. So, the AC box that we have in this picture is called an electric vehicle supply equipment. I will explain in a minute what it does. And usually the power ratings of these EVSEs, like they can come in 2.3 kilowatts, 3.3 kilowatts, 7 kilowatts, 11 kilowatt, 22 kilowatts, and so on. But depending on what your home supply can supply, you can install different kind of these devices. And generally, most of the EV users who buy EVs currently, the manufacturer will give a free of charge 7 kilowatt wall box like this, which you can install at your home. and I will explain further happenings around those boxes later. And fast chargers that we have in Sri Lanka currently are 30 kilowatt, 40 kilowatt, and 60 kilowatt. So we will know the details later as we proceed with the rest of the slides. And we call this AC charging, L2 charging, also level 2. And DC charging is sometimes called level 3 charging, also DC charging, fast charging. This fast charging term generally is used in EV context for DC charging. Now, without this knowledge, there have been instances where people make videos on how to use this 7 kilowatt wall charger. They call it a charger, and they call it fast charging using 7 kilowatts. Yes, relatively it is faster, but in EV terminology, it is not called a fast charger. Generally, we use the term fast charging to explain DC charging. Now, this portable EVSC, every EV will come with one of these at minimum. Now, the newest EVs that are sold in here, they come with a portable EVSC like this, as well as a wall EVSC that you have to install at home. Now, the portable one is to be used when you are traveling, when you are at a different location. If you want to charge the car, maybe at your friend's place, your relative's place, you can use this one to charge. Let's understand the technical capabilities of these EVSCs. Now, they work on 230 volts AC. This is not a charger, but a controller. Charger will be inside the car. This controller will talk to the charger and say, if it is a 10 ampere EVSC, it will tell the car, you can draw 10 ampere maximum current from the wall plug, not anything more. Then the car will decide, okay, now if the VSC tells me that I can only draw 10 ampere, I will stick to that level, because if you draw more, the wall socket can get damaged if you draw higher current than that. So the charger inside the car, we call in EV language onboard charger, or OBC. And this particular EVSC comes with a 13 ampere BS1363 plug. So all the electrical engineers know these things, but in the interest of others, I will briefly explain what this 13 ampere socket and the plug gives us in terms of safety. Now, our current country standard is moving towards this plug and socket. Eventually, the expectation is, like in time to come, all our wall sockets will be 13 ampere. Square pin, we call it square pin, right? And all the new installations at the moment need to be done with this kind of plugs and socket, this kind of sockets. Now, this plug, you can see there's a fuse, and there's a rating marked here, 13 ampere. If you are drawing using an equipment which draws lesser current, you can install a fuse of a lesser value. So what will happen is, in the case the equipment draws higher current, this fuse can get blown and the circuit will be disconnected. Now, this fuse is not to protect your equipment. That's a misconception that most people have. That's why I want to clarify here. This fuse is there to protect the wiring of your wall and this socket, because this socket and the wiring is designed to handle only 13 amperes maximum current. So by putting a 13 ampere fuse, if the current values exceed, it will automatically disconnect the circuit. And the second feature on this plug is that you can notice the earth pin is longer than the other two pins. So what happens is, the earth pin is wired to the outer casing metal surface of your equipment, And when you plug this in, before the live and the neutral makes contacts with the socket, the earth pin will make contact. That means your equipment surface will be connected to the earth before you even connect the electricity supply to the equipment. What does it mean? That means the moment you plug the equipment, if there's a leakage of any sort to the outer casing of your equipment, the current will flow to the ground without impacting the humans. Now, it also applies to the car also, but the car has some additional protection because the moment you plug, the car will not start charging because this EVSC will then start doing some uh, power on test and tell the car, okay, now you can start. Then the car will also do some diagnostic tests, check the connection, check earth and all these things. And then only it will start drawing power from the wall socket. So in case of EV, this earth pin story is not directly related, but earth connection is critical because the car's body needs to be earth because during charging, because this AC supply, if there is a leakage to the car body, if somebody goes and touches the car, there can be problem because somebody can be seated inside the car also. So, of course, car vehicle manufacturers put a lot of other safety mechanisms inside the car to prevent those things from happening. But I'm just trying to explain the principles. So we have this EVSC equipment. Let's apply the same formula into this EVSC capacity, and we can rearrange this formula as amperes equals watts divided by volts, and apply the specification of the EVSC 2.3 kilowatts. We say we can decide, okay, now this EVSC will draw 10 ampere current because its capacity rating is 2.3 kilowatts. Now, we know our car battery manufacturer might tell us the capacity of our battery. And we can rearrange the capacity terms as watt hour into watts. That means battery capacity is watt hours, power given to is in watts. So we can determine the time taken to charge this battery like this. Yes, 22 hours. So that's going to be a very long time. But this is a basic principle. I have given these formulas to illustrate the idea. So there can be variations into these calculations. Like there's of course, when you get a 50 kilowatt hour battery, the EV will not use 100% of the capacity of the battery. It will keep some reserve before it says, I cannot drive anymore with this battery. So what you will be charging is less than 50 kilowatt hours. But on the other hand, you will draw more power from the grid because there will be losses. There's about usually a 10% need to be factored into the losses of AC-DC conversion during AC charging. So let's talk about the cable capacity now, because most of you may be having electrical engineering background or understanding. Let's try to emphasize this because my expectation is that you will take these messages and propagate it to ordinary EV users as well. What most people don't understand is this current carrying capacity of cables. Now we use 1.5 millimeter square or 2.5 millimeter square cables in our domestic wiring. Now, as you can see, as per the British standards, the 1.5 millimeter square cable can carry 15 amperes. But as shown in the bottom table, depending on the operating temperature, you need to descale. There need to be some correction factors applied. On the other hand, all those who have learned city or electrical engineering know that there can be power losses in the cables. What is the formula? I square R. When the current increases, the losses increase exponentially. And so will it if the resistance increases in the conductor. So that is why for a given cable cross section, there are ratings of maximum current drawn, because if you try to draw higher current because of the resistance, the current carrying capacity will not be there. And also, one thing about the temperature, during high current, the cable can get heated up and temperature can go up, and increased temperature can even increase resistance. So all these things matter when it comes to electric vehicle charging, because the amount of current that you are trying to draw from the wall socket, if it exceeds the design specifications of your home wiring, you might immediately not notice, but there will be long-term damage to your home wiring. It can be your home wiring, it can be your friend's home wiring, it can be your relative's home wiring. So unless you understand the principles behind the capacities of home wiring, it is dangerous to go and just plug your EV charger or the EVSC into any plug that you see. Just because there's a 13 ampere socket doesn't mean that there's a 2.5 millimeter square cable behind it. So it is best to ask and verify whether the socket has been wired properly according to standards by a qualified electrician. If you are not sure, then avoid plugging your EV to these kind of sockets and causing unnecessary costly damage to that person's premise wiring. So that is one thing that we need to be aware of. Now, just to give some examples, let's assume that we derate it by 80%. So the 15 ampere maximum capacity of a 1.5 millimeter cable can deliver, let's say, 12 amperes. Because for EV charging, you have to understand that this current will be drawn for number of hours. So it can be 2-3 hours, or it can be 5-6-7 hours. So the cables tend to get heated up. So because of that, you should avoid loading these circuits whenever possible. In a sense, for a short period, yes, you can draw high current, but remember, if you use it for too long, you might damage the wiring. And the best for about 15 ampere current is using a 20 ampere circuit. So 20 ampere circuit means 2.5 millimeter cables have been used for wiring. So these things need to be understood for home charging to be done effectively and safely. People who don't understand these principles go and try all sorts of things and create problems for themselves as well as others, and risk the safety also. So the portable EVSC that you might get in your new EV today will be a 10 ampere. Generally, most people will give a 10 ampere EVSC as a portable device, and that can be safely used in 13 ampere sockets wired with 1.5 millimeter cable. But if you are doing it at home, better get a new circuit done using 2.5 millimeter cable so that the cables won't get heated up at all. It's a kind of over-engineering, but it ensures safety. And if somebody is using a Japanese Nissan Leaf compared to UK Nissan Leaf, because Japanese one comes with a 15 ampere EVSC, whereas the UK one comes with 10 ampere because that's the standard used in UK. So the Japanese one requires a socket like this, and there are wall sockets also which are available in the same type. This is of course a extension cord socket. So now we know something about the EVSC. let's try to do some different calculation. So we know our battery capacity is 50 kilowatt hours and the EVSC power is 2.3. So we calculated charging time to be 22 hours. Now when we buy an EV, so one of the marketing slogans they use is the range. So our EV can run 400 kilometers. But most manufacturers don't, or most salespeople don't tell you 400 kilometers in what standard. Now there are multiple standards of specifying the range of an EV. The most common ones now are, there's one called NEDC. It used to be common earlier. Now there's a new one called WLTP, which they consider is as close to normal usage as possible. Now the Chinese vehicles, they quote range in CLTC, their Chinese standard. Now that standard tends to be much more conservative than our actual usage here. So if a salesman comes and tell you, okay, this EV can do 400 kilometers, please ask under which standard. If it is CLTC, you need to accept the fact that it won't be 100 kilometers under WLTP. WLTP is a more generalized version of this range estimation, which will be suitable for our usage here. So that is one of the traps that people get in because they don't know the difference. When you want to compare two EVs, if one manufacturer quotes 400 kilometers in WLTP standard, the other one does in CLTC, they are talking about two different things. So we can roughly estimate the range ourselves. So if the manufacturer says 400 kilometers and our battery capacity is 50 kilowatt hours, assuming that the battery will be discharged to 0%, we are not going to do it in real life anyway. So that means we can do 8 kilometers per kilowatt hours. That is a mileage. Like in a gasoline car, 19 kilometers per liter. Here we calculate number of kilometers per kilowatt hour because that is our unit of measurement of energy. Now, as a general value from my experience, most people in Sri Lanka will do 5 kilometers per kilowatt hour in any EV, most of the EVs. But this can vary depending on the driving style, terrain, traffic conditions and all these things. But generally, we can take it as a ballpark value that you can do 5 kilometers per kilowatt hour. What does that mean? If I charge using my 2.3 kilowatt EVSC for 1 hour, I am getting 2.3 kilowatt hours. And that into 5, so I'm getting 11.5 kilometers. You can factor in some losses or anything, but let's say assume 10 kilometers. Now that means if I charge 1 hour, I get a range of 10 kilometers. Now, this is the mindset you have to start building. When you want to travel a certain distance, just roughly mentally you can calculate how many hours of charging I will have to do using this portable charger. And if you are not going to use this portable charger or EVSC, you are going to use wall-mounted high-capacity EVSC, then depending on the capacity of that EVSC, you can roughly estimate the amount of hours that you will need to spend for charging before the trip and then on the way back also. Then you need to allow this much of time before your return trip so that you can charge if you want to charge using AC. Now let's take the wall-mounted EVSE and apply the same calculation. Now wall-mounted EVSEs can come in 7 kilowatt, 11 kilowatt, 22 kilowatt. These are the common values we see. And the 11 and the 22 can be 3-phase AC because we cannot anyway supply more than 7 kilowatt through our domestic AC supply, single phase AC supply. And let's take the battery capacity of 50 kilowatt hours and calculate the charging times. So you would like to have a 22 kilowatt EVSE if possible, so that you can charge within 2.72 hours for a battery capacity of 50 kilowatt hours. But in reality, we cannot do these things. These numbers looks very nice, but we have practical limitations. Of course, for reference, I will show you my good old Nissan Leaf's capability. It came with a 24 kilowatt hour battery in those days with a 3.3 kilowatt EVSE. So to fully charge, I needed only 7.27 hours. So overnight you can charge. Now with this high capacity batteries, you need more time to charge or you need more current to charge. Now as you can see, the 7 kilowatt EVSE will draw more than 30 amperes of current. Now we have a problem. Our domestic tariff we can have in Sri Lanka is like this. There are 3 tariffs, 30 ampere single phase, 30 ampere 3 phase or 60 ampere 3 phase. So majority of the households have 30 ampere single phase. So you can reasonably assume I can draw 30 amperes to my EVSE and to my car with this. Of course, you cannot use these other EVSEs with single phase supply. And if you have 30 ampere 3 phase, comfortably you can use a 7 kilowatt in one of the phases, and maybe you can manage to draw up to a certain limit on these other type of EVSEs also. But there's a problem. Of course, the cost increases not in terms of tariff, but initial installation and upgrading cost. If you want to upgrade from 30 ampere single phase to 30 ampere 3 phase, CB will charge you for the new drop cables and things like that, new meter, and you will have to wire your home premises to accommodate a 3-phase supply. So the 30 ampere limitation remains for most households. The second problem is, yes, you can give 30 ampere to your EV, but what about your household usage? Are you going to switch off all the lights, all the equipment, your refrigerator, everything, and charge only the current, only the car? No, right? So this is a problem. Because if there's let's say, load, your AC is running, your refrigerator is running, you want to watch TV and all these things, the house draws 12 amperes, but the total current you can get from CB is 30 amperes. So your car cannot really get 7 kilowatt and it cannot really charge in 7 hours. It will take much more. Now, this is the problem. This was a problem experienced by many new EV users who started buying EVs since last year. So they got a 7 kilowatt wall EVSE and they got some electrician to just wire it. And then in the night, they plug the car for charging. And after a while, after maybe 10 minutes or maybe 1 hour, the whole house loses power. And then now they want to charge the car also. So they remain in the dark in the house and try to restore the circuit to power up the EVSC, and somehow or other manage to charge the car. And then this became a big issue and people started crying foul over what the hell, I bought an EV and I got a high capacity EVSC and I have a big capacity battery, but I cannot charge it at home. Now, do you know the reason? Now, most people don't know the operation of a circuit breaker. Now, the circuit breaker is there to protect the circuits. When if the equipment draws higher current, the circuit breaker will also disconnect the circuit. Now, there are two mechanisms that are happening inside the circuit breaker. There's a solenoid-based plunger mechanism which disconnects the circuit when there's a very high instantaneous current flowing. That means a short circuit current. If there's a short circuit in the equipment, very high current is drawn within a very short period of time, the circuit breaker trips. Now, the second case is the current always passes through a bimetallic strip inside the circuit breaker. Now, the bimetallic strip is designed to handle certain current. Beyond that, it gets heated up slowly, and that at a particular moment, if it bends too much, and the electric path gets disconnected. Now, this is what is happening with the EVSCs. You start charging, the circuit breaker will allow you to draw a higher current, but if the current prolongs for a time period, the bimetallic strip gets warmed up and it will disconnect the circuit. So that your house will be without any power. So this is why it is important to understand all this background, and otherwise you need to talk to somebody who knows all about this. So my lecture today is going to be very interesting because I'm talking to a lot of engineers here. So they can take this message and spread it among all the EV users and all the potential new EV buyers, so people understand what to do when these things happen. So the solution given by charging service or charger suppliers or EVSC suppliers, I would say, is to incorporate a feature called dynamic load balance. Now let's see in the next slide what this dynamic load balancing is. Now in a typical household, you will have your house wiring like this. CB will have a breaker next to the meter, and that is the breaker I was talking about in the previous slide. So it is rated to give you a 30 ampere current, but it will allow slightly higher current for a shorter period of time. And then you have your main breaker, trip switch. By the way, trip switch is there to save lives, not to protect your home or not to protect equipment. It is there to save lives. The moment an electricity leakage happens to your body, there will be a current imbalance created in the trip switch and it will trip. So you need to have a proper rated trip switch for your home. The standard is 30 milliampere rating, because more than 30 milliampere traveling through your body, through your heart, your relatives or your family will need to call the undertakers for sure. So you need to protect the human beings at your home, so you need to use a trip switch. And you have a 30 ampere supply. Now this EVSC with dynamic load balancing will have a special wiring in your home. Now anyway, for your EVSC, you need to have a separate circuit with separate trip switch. And this need to be taken from the main bus bar. So that will not interfere with your house load. The EV charging will happen from the CB side coming directly to the breaker for the EV circuit. And you need to have a surge protection device also installed in this circuit, so that in case of a voltage surge coming from the grid side, your EVSC will be protected. EVSC and the car will be protected. So what we do in the dynamic load balancing is, let's assume that you are drawing 12 ampere current to your household usage. We measure the current and then we feed that input to the EVSC, which has a capability of balancing the load dynamically. Then what will happen is EVSC will calculate the amount of current the car should be drawing, and it informs the car. Then car will know, okay, although I have a 30 ampere rated EVSC wired, but my EVSC tells me it can only provide 18 amperes. So I will only draw 18 amperes, and this will happen dynamically. When the house loads varies, this EVSC will keep on telling the car, now please reduce or please increase. So car will draw different currents at different times. Because of this, it is not very easy to estimate the time that will be taken for the car to be charged. So that is a difficulty that people have with this dynamic load balancer. Because you can, through experience only, you can do that, because when you plug the car in the night between certain time period, so over a period of time, if you keep a record of how things went, then you will know I will need exactly this many hours to charge this percentage of battery. Now, this EVSC, the other reality is, I highlight this as a problem. Of course, you can have a high capacity EVSC at your home, but the vehicle itself will have a limit on the capacity of the built-in charger inside the vehicle. Now, typically for the BYD vehicles, it is 7 kilowatt. For good old Leaf, it is 3.3, or the later models, it is 6.6 kilowatts. For some other manufacturers, the manufacturer specification should tell you what is the capacity, because some data sheets I have seen with some Chinese EVs, AC charging, yes, that's the specification. But they don't tell you what kind of capacity the built-in charger has. So if the buyer is not careful, or if the buyer doesn't go and verify what is the capacity, he's expecting, okay, I can install a 7 kilowatt EVSC and charge this car and all these things. He's building his dreams, but when he brings the car, he might find that it has only 3.3 or 3.6 kilowatt charger, has the onboard charger. So you need to be very specifically asking the capacity of the onboard charger when you're buying a vehicle. Now let's come to the interesting part. Now this AC charging, there is a plug like this. Now the problem is there are multiple standards. Now all the Japanese the vehicles imported from Japan, be it any brand, they will have a 5-pin connector like this, and it is called J1772 connector, because that's an IEC recognized standard connector. It has, as you can see, it has pins for live wire, neutral wire, earth, and control pilot and proximity pilot. The proximity pilot detects whether the plug has been engaged, because as we talked about it, we are drawing high current, so we have to ensure that all the contacts are made very clean and good. So from the car side, there are some checks being done using these signal pin. These two are signal pins. Control pilot is the EVSC communicates to the car by sending a pulse coded modulated signal to advertise the current capacity of the EVSE. That means when the current, if the EVSE has a fixed current rating, it will advertise that. Or if it has a dynamic capability, instantaneous current drawing capability will be transmitted to the car, and the car will adjust its charging speed according to that. And this particular type of gun has a latch. That means when you plug this in, the latch engages here, and there's an internal mechanism which we can control from the car, which prevents anybody from pulling this out while it is charging, or even after charging. There are different modes of blocking this. Now this of course can accommodate only single phase. Now we call this type 1 connector, type 1 AC plug, and all the Japanese, Korean, and any Chinese EV that have been imported into Japan and imported into Sri Lanka as a used vehicle will have this type of AC charging plug. And all the newer EVs will have a different plug. Note that there are different number of pins. Of course, if it is a single phase, we use only L1. And if there are 3 phases, the car also should support 3 phases, then all 3 pins will be connected. The plug has all both capabilities, being a single phase or 3 phase. Now this we call type 2. So all the new European and all the Chinese EVs brought into Sri Lanka, they fix this standard in the vehicles so that it will be compatible with the charging stations available here. So now what will happen if I have a type 1 wall charger in my home and my friend has a BYD which uses type 2? He comes to my place and asks, Machan, can I charge from your charger or your EVC? The answer is no, right? Because these are 2 different types. But there is a solution. There are conversion adapters available because we are talking about just supplying AC into the car. So it's only the physical interface that differs. Generally, the protocol for EVSE to inform the current level that remains the same. So we can buy these kind of adapters. So the person who comes to my place can buy this type of adapter and plug to my EVSE plug, and then plug this one into his car. So same way, I can keep an adapter so that if I visit a EVSE which has a type 2 plug, I can charge my type 1 car. So generally, these are not very expensive devices because mostly it's a physical converter. So we can buy one and keep in our car. So we can go to any AC charger and charge our car. Now DC charging, on the other hand, is slightly different because the charger itself provides very high current, high power. Usually now most of the battery electric vehicles, the voltage can go up to about 400, or now there are latest EVs in the world being produced, especially in China, which uses 800 volt batteries. Because the whole idea is when the voltage is high, the cable cross section that needs to be used for the current becomes smaller. That means reduce cost. Even inside the car, so there are 400 volts cables, and if you increase it to 800 volt cables, the cost of the DC cables will become cheaper. There are a couple of problems with the DC fast charging, also practical problems. Now, in Sri Lanka's context especially, the vehicle may be capable of accepting high power DC fast charging, but our charging stations may be limited on the maximum power that can be delivered. Now, this is due to some limitations in the CEB supplies and the cost of that supply. It's cost of a new transformer and things like that. So charging center providers are facing these difficulties when CB says, yes, we can give the supply higher current, but you need to buy a transformer. Then the cost of the transformer needs to be recovered from the EV user, which means the charging station needs to increase their rates. That means most of the EV users will not be able to, will not come to their charging station. So they have to balance this out. So EV's charging power can go up to 150 kilowatts, but maybe the fast charger can give only 30 or 40 or 60. That's the reality in Sri Lanka. Problem number 2, now fast charging, there are multiple standards. That means I cannot just go and charge my car from any EV charger out there. The standards that the EV charger use and the standards that my car or the EV use needs to match. So how do we get around it? To do that, we need to understand the charging standards used. Now, back in the Nissan Leaf days, because that's the world's first mass-produced electric vehicle, Nissan launched this in Japan and then in the US and then in Europe and all over the world. They didn't come to Sri Lanka. Of course, Sri Lanka got the Nissan Leafs, has used cars from Japan. The early adopters, even myself, I personally imported my Leaf from Japan as a used car. So they have these different port and plug. And US, when they launched Nissan Leaf in US, there are other manufacturers also trying to make electric vehicles. So they came up with their own charging standard and they call it common charging system. And then Tesla came. Tesla built their own standard with their own plug. So the Tesla cars came with this plug. And Tesla started building charging network around the country called Tesla Supercharger Network. So in the US, they had 3 standards. So depending on the vehicle type, they needed to go and find a fast charger which is compatible with their vehicle. Then Tesla introduced a converter so that, because at that time there were more demo chargers in the US because of the popularity of the Japanese and the Korean EVs. So Tesla released an adapter so that Teslas can use the existing charger network as well. But the other way around was not possible, and then later they had some adapters, I think. And the European manufacturers, they came up with their own standard, which was basically an adaptation of the fast charging standard CCS plus the AC charging standard. They built their type 2 plug. And they created a combo plug like this for signaling. The DC fast charging also uses some parts, 2 pins from the AC plug. Now, unlike in the Japanese standard where you have 2 distinct ways and there are 2 signaling pins and 2 power pins, the CCS standard is different. Similar to CCS1 also, CCS1 uses the AC plug as type 1, whereas CCS2 uses the AC plug as type 2. Otherwise, these 2 protocols are compatible. Now, in 2023, Of course, while this was happening, Tesla was exporting Teslas to Europe, and they ship the European versions with CCS2 charging sockets, so that if we bring these cars to Sri Lanka, we could survive with CCS2 chargers here as well. There are few uh, Tesla supercharger and CCS Type 1 Teslas also in the country, but they don't visit the public charging infrastructure anymore. So they have their own private chargers at home, fast chargers. And in 2023, or before that even, Chinese manufacturers, they have their own standards called GPT. And 2023, US Standards Association, they decided they will do away with multiple charging standards and going forward adopt Tesla's standard as North American charging standard. Of course, the old vehicles will still rely on old charging networks, but new vehicles will come with this standard, and they can use new charging networks that are being rolled out using the Tesla standard. On top of that, India, they came up with their own standards a couple of years back for electric three-wheelers and electric bikes, then which uses a totally different plug and different standard. Internationally, nobody else has adopted these standards so far. And sometime recently, somebody asked me, probably he's planning to bring a electric bike from India, which has this standard. So unfortunately, if he brings that bike here, he'll be the only person using that standard, unless our charging service providers think of providing this standard, because now very likely there will be Indian electric bikes which will come to Sri Lanka as well, which uses their own standard. Now in India, they have deployed a lot of charging stations using this standard. So this is something new happening. This is something new that I also got to know quite recently. So let's summarize what we have. So we need to pick and match from these available different standards. Europe uses Type 1, Type 2 AC plug, and Japan uses Type 1 AC plug, and Japan uses CharDemo, and CCS2 is the Europe standard. We call the AC charging level 2 charging also, and FC or L3 charging for the DC. And if we eliminate all the other standards, we are left with 2. Because at the moment, there is a vehicle population about 5,000 vehicles or more using CharDemo standards. So this standard is not going to go away very soon until these vehicles go out of the roads. So in 2019, the Public Utilities Commission of Sri Lanka decided, going forward, we will quote CCS2 combo as our national standard, and all new EVs that come into the country or that are being brought into the country as brand new vehicles by the respective authorized agents need to comply to this standard. So if anybody brings any other kind of charging plug, then the user will be in trouble. Because recently I discovered that there has been a vehicle imported into the country, a Chinese EV using Chinese fast charging standard GPT. But unfortunately, the same model, all the other vehicles imported into the country have CCS2. So that particular user has to go around looking for a GPT fast charger. Of course, one of the charging service providers, ChargeNet, has implemented GPT standard charging stations because they are doing this electric vehicle conversion for electric conversion for three-wheelers. And for that, for cost reasons, they are incorporating the Chinese standard because the development cost of these other standards are comparatively higher than the Chinese. Of course, probably they can buy the equipment at a cheaper cost for this conversion because the cost has to be attractive to the three-wheeler owners for them to convert their gasoline-powered three-wheelers into electric. So most of the new EVs that you purchase will have this kind of socket. Apart from that, the traditional charging service providers might provide these kind of wall sockets at charging stations so that if you carry your portable EVSC, you can plug that 10 charge also, because in the event that the charging station is already occupied and there's a long queue or something, these kind of sockets will provide additional means of charging your car instead of waiting in the queue. So if you take a summary so far, you need to understand in principle, we have two standards for AC charging, two standards for DC charging, and the internal capacities of chargers for AC charging may vary between vehicles. Now the BID vehicles marketed in other countries come with 11 kilowatt inbuilt chargers as well. It depending on the market. And now fast charging capability, generally the oldest Nissan Leaf is about 45 kilowatt, and then it has increased to uh, 50 kilowatt in subsequent models, and the later models even up to 150. Again, same story with BYD. What is being marketed here right now gets limited to about 70, and depending on the model, to 88 kilowatt inbuilt onboard charger. But in other markets, there can be vehicles with high capacity onboard chargers. Now, we talked about converters. There has been a development in converter for CCS to char demo, so that char demo car can go and charge from a CCS to charger. But these adapters are quite expensive at the moment in dollar terms, and also may have compatibility issues because there's a lot of complex protocol conversion that need to happen for these things to work. And what I have heard is it's not successful with every type of car and every charger. So there are incompatibilities between the charging station and the adapter, as well as adapter and the car. So it all depends. If you buy one, you can try. It might work in one charging station, but it might not work in a different charging service provider's charging station. Now let's talk about public charging. So we have reached 1.5 hours, or is it? Can we continue, or shall I quickly conclude after these few slides? Supun?
Yes, Engineer Janaka.
I
Sure,
think
you can continue.
better you
Yes,
appreciate you to continue.
okay. So there are charging service providers. Now, I'm not promoting particular charging service providers only, but for easy adaptation into slides, because I could only capture good graphics from these two charging service providers, I'm using them. So one charging service provider is ChargeNet. We'll talk about them later because of that, because they have nice graphics available in their website. I just picked them. So they are one of the pioneers in electric vehicle charging in Sri Lanka. They develop their own chargers locally. They manufacture their chargers locally. So they have charge demo only chargers in the past, because majority of the vehicles were charge demo only. And lately they started introducing dual mode. That means both charge demo and CCS2 plugs are available. And then volt charge, of course, the brains behind ChargeNet went away and started volt charge, I would say that. And they are also a totally local company. They manufacture chargers locally, and they have partnered with John Keels to set up fast charging centers in all the Keels supermarkets, and they are selling these chargers to other places as well. So they always have a charge demo CCS2 dual mode charger, and ChargeNet also has AC level 2 chargers, and both type 1, type 2. Some of the ChargeNet charging stations have both these units separately. So that means one car with type 1, one car with type 2 can charge simultaneously. And ChargeNet dual, and both these operators dual plug charging stations. Some of them can accept simultaneous charging. Some of them only one type of car can be charged at a time. So you have both plugs, but only one car can be charged at a time. And apart from that, some traditional charging service providers, they provide additional sockets also for you to charge. And there are a lot of new chargers being set up island-wide, like reputed European brands like ABB and also Chinese brands. So this domain is expanding very rapidly. It is hard to keep track of all these things and how you charge. So let's quickly talk about it. Of course, the capacities, they also keep changing, because now we saw 30 kilowatt charging stations earlier. Some have grown to 60, and some have grown to 40, and new ones are coming up with 40, 60 likewise. So these things are changing depending on the location. I think CB is also facilitating more charging power to these investors who set up charging stations. So we see a healthy growth of charging stations. For new EV users, I would say things are becoming much more better than what we used to have during the last 10 years. So you can use these kind of EVSCs on these sockets. And there is currently an issue, because now each charging service provider, they have their own app to pay for the charging. So of course, I mean, that is understood, because they have means of interacting with their own charger and then collecting money from the user using credit card or debit card. So most of them operate on a wallet basis. That means they have a wallet, electronic wallet. You top up some money into that wallet using a credit card or debit card, and at the charging station, you have means of activating the charging based on the time or based on kilowatt hours. And some like ChargeNet, they have even the percentage, like your battery percentage. You can say charge my battery up to 80%, or charge my battery up to 15%, or charge my battery with 10 kilowatt hours. So if you have a good understanding of all these terms that we discussed, then you can decide which way is better for you, depending on the situation, depending on the time you have, and depending on the amount of charging that you need to do before you head to your next destination. Currently, I think there may be one or two more, which I'm not sure. I need to keep updating these slides. Difficult thing, keeping a track of all the new players that come into the market. And so to address some of the problems, there are aggregate apps. Now, these apps cannot be used to charge at the charging station, but they can be used to locate the charging station when you plan your trip. The most common one was plug share, which was available even 10, 15 years back. That is a crowdsource application. It's an app available worldwide. The problem with that is I always call this a garbage in, garbage out app because anybody can post location of charging stations into that. Now, over the years, many people have populated the locations, but the charging service stations have gone out of business. They are no longer there. But nobody has gone and deleted these entries because initially the way was for the person who added the location to go and delete it. But now I think there's a way to report it, and then if there's a voting mechanism that some people can delete, have the permission to delete them. But I don't know exactly how it happens now. But we have a better solution in Sri Lanka. There are two more apps like Recharge LK and EV5. And I'm particularly promoting EV5 Lanka app. One reason is it was developed by one of our EV club members who have been an EV user for a long time, like me. And he knew exactly the pain point of EV users, uh, all the new EV users in trying to locate the charging stations. So he created a nice app a few months back, which he puts a deliberate or very diligent attempt, I would say, to update with every detail as and when they come up. So that lists the entire charging infrastructure in Sri Lanka. Put it that way. So whenever a new charging station comes up, if somebody tells him, he will quickly go and update the app. And the app itself has quite a nice set of features. So this will help you to locate the charging station. Now these uh, big numbers in big circles indicate the total number of chargers available in that particular area. So when you zoom in, it will expand into showing you individual charging stations like this, what you see now in Batiklo. Now, on the left side is because you can click on the plug types. On the left hand screen, I have clicked CCS2 and Type 2 plugs for fast charging and slow charging. On the right hand slide, I have clicked fast charging for DC char demo and slow for Type 1. So you can see the distribution of charging centers available for CCS2 and char demo. Of course, you see there are more and more CCS2 charging stations, CCS2 and Type 2 charging stations coming up, which is expected. We get because we are increasing the vehicle population of CCS2. So this is the current snapshot. I took these screenshots today, just few hours before this presentation. So it should be the latest. And furthermore, when you click on each location, it expands into showing the actual physical location, and it shows you the charging center operator. This is the application app that you need to install on your mobile, and it shows the operating hours and type of connectors. And now if it has multiple connectors, multiple types, it will show the details here and the unit price. And also it shows kind of the amenities available at the charging station. Now, for example, now this is of course the beach hotel. They have toilets, they have some area for people to hang around. They have food, and there are level 2 charging service providers who are really restaurant operators. So you can stop for 1 hour, charge the car for 1 hour, have some food there. So it works either way. The restaurant owner also gets a benefit, and as an EV user, we also get the benefit. Now, these operating model of charging stations, fast charging stations are all unmanned, I would say, today, except one or two, because if you have manned charging stations where you can pay cash, you need to employ a person full time to do the payment and accepting the payment. So that means it increases the cost of the charging center provider, which gets passed on to the user anyway. So another misconception that I need to clarify here is, now you see, AC charging is 80 rupees a unit, fast charging is 142. Now, fast charging doesn't have to uh, cost the same as slow charging. Yes, electricity cost is a different thing, but running a charging center infrastructure is a totally different thing. Running a small EVSC for slow charging is very affordable thing, but running a DC charging station, the infrastructure cost is very high, so the charging service provider needs to recover that investment. The return of investment period is very long for charging service providers. We need to understand, and that was the very reason that charging center providers, which entered the business in the last 10 years, some of them vanished after a while, and they couldn't recover their investment because their government policy on EVs were not progressive. When they increased the taxes on EVs, people stopped bringing in EVs, and so that created a decline in the revenue of charging service providers. So they slowly went out of business, and that was a big issue for EVs users who bought EVs on the expectation that EV industry will expand in the future. But hopefully, we would not see that happening now because we see a lot of investments here. So, in terms of how to manage your charging, now you know, you don't have to worry too much about charging. Finding charging stations. The infrastructure is there. The applications are there. It's just that you need to apply this knowledge and figure out how to manage that situation. Now, one more thing I need to tell you before I go to the next slide. Now, always try to think of charging what you need. Now, if somebody needs to go to work every day, you know how many kilometers you will run. So charge that and leave some safety margin for your ad hoc trip, and do that charging only daily. When you need to go out station for a longer trip, then plan the charging accordingly. But for your daily running, you don't have to always end up in a charging station, or you don't have to always top up your battery. Now, there are different store theories about battery topping up, depending on the battery technology. And most new EV users will get an LFP battery, which is chemically different from the lithium-ion batteries that we have called NMC and CM, because they use nickel, cobalt, manganese, whereas the lithium-ion batteries, which uses lithium ferrous phosphate, they tend to have a better endurance for charging and better endurance for heat build-up, better endurance for temperature rise. As a result, they tend to last longer, or expected to last longer, because historically most manufacturers used the nickel, cobalt, manganese these type of lithium-ion batteries, and they degrade over a period. Compared to LFP batteries, they degrade at a faster rate. So there are different charging regimes that you need to follow depending on the battery type you have. Let's first understand some terminology. Now, in a given battery, lithium-ion battery, whether it's an EV or your mobile phone or your laptop or whatever device, the battery manufacturers quote a cycle count. That means there are a number of cycles that you can charge and discharge the battery. Now, a lot of people get this kind of confused with this terminology as what is called a cycle. So let's assume I have uh, 3 glasses like this. Now, glasses have same capacity, but I mean, for when I created these slides sometime back, I picked a picture of a glass which was shaped in V shape. I should have used a square glass, but it doesn't matter. The concept remains the same. Now, let's assume that I charge this, fill this glass fully up to the brim, and then I discharge it fully. I empty it completely. Now, that charge-discharge cycle we call single cycle. Now, if I fill it up halfway, well, let's assume this is 50% of the capacity, also the shape is different, and discharge, I have consumed half a cycle. If I do it 3/4 and discharge fully, I have consumed 3/4 of a cycle. Now, if I use one cycle today and another cycle tomorrow, after 2 days, I would have used one cycle. Oh, sorry, if I use half a cycle today and another half tomorrow, I would have used one cycle in 2 days. So that is how you calculate the cycles. Because if you discharge only partially, then that is not a full cycle because your charging is full and you discharge halfway. You may consider that you have consumed half a cycle because the top half is also a half. The bottom half is also a half. So that is how you understand the number of cycles. Battery manufacturers will tell you, generally the cell manufacturers will quote a cycle count, a range of cycle counts, I would say. So what it means is, if I buy a battery cell from manufacturer A, if I buy a battery cell from manufacturer B, if their cell chemistries are different, their cycle count may also be different. Now, lead acid batteries have, just to give you an idea, have a cycle count of about 300. 300, 200, 300. That means if you fully discharge and charge battery every day, you cannot even use for 1 year. So during operation, you might not fully charge and discharge a lead acid battery in a vehicle. So you might use it for 2 to 3 years. That's it. After 2 to 3 years, anyway, you'll have to change. So the battery is gone. Similarly, lithium-ion batteries, they can last something from 8 years, 10 years, likewise. Because NMC batteries, the cycle count is, say, around maximum 2000, I would say, just for comparison effort. And lithium iron phosphate batteries will give you about 3000 to 4000 cycles. So comparatively, they are about 50% to 100% higher cycle count. It all depends on the manufacturer's chemical composition. Now, capacity degradation is another thing. Any battery, you know that your mobile phone battery, when it is brand new, it can hold a higher capacity. Over a period of time, after 1 year, after 2 years, the battery capacity degrades. Same thing happens to electric vehicle batteries. Now, the brand new, it might have capacity like this. But after maybe a T1 time has elapsed, due to your charging, discharging, and due to calendar aging, batteries degrade over calendar period also. Even if you don't charge and discharge them, if you leave it alone, also it will degrade in capacity over a period of time. So what will happen? The size of the glass reduces. That means physically your battery will have the same dimensions, but your capacity has degraded now. So the best thing to compare the capacity degradation is your glass size gets smaller, then the amount of water that you can fill into the glass becomes lesser. That means the amount of energy that you can store in the battery becomes lesser. That means the amount of kilometers that you can run from a full charge of this battery gets reduced. So this phenomenon is a common thing for all batteries. So electric vehicles, same way. Another term that we use in electric vehicle language is state of charge. That is percentage charge in your battery, in your current capacity. That means if I compare three batteries or three EVs, each having different capacity batteries, because now one may be brand new, one may be 2 years old, other one may be 5 years old. They talk in 50%. No, I charge 50% and travel to Gaul. The other guy said, I charge 50%, but I cannot reach Gaul. I had to exit probably in Kadua and charge it and then go. Another guy say, oh, I cannot even reach a Valipan risk point with my 50% charge. Why? Because they are not talking about the same thing here. My 50% and your 50% might be different depending on the actual capacity of the battery. So when you try to compare your vehicle with a friend's vehicle, yes, up to a certain level you can compare with percentage, but when the battery capacity degrades, this comparison becomes not valid. Then there's another parameter called state of health. Now, as shown in the bottom here, the third class has a less capacity now, right? It has got shrunk. Now, to reflect that phenomenon, battery manufacturers use a term called state of health. We can simply consider that state of health value represent the size of the glass or the capacity of the glass. When you say state of health has come to 90%, we can reasonably assume that the battery now can store only 90% of the original capacity. There are some other parameters that get into, because each vehicle manufacturer, battery manufacturer, they have algorithms on how to do some measurements in the battery and come up with this value. Using test equipment, we can access the battery management system and read this value. But generally, they are not shown to the EV user on the dashboard, but some vehicles may. For old Nissan Leaf vehicles, there was a free software that was written by some EV user. He released it free of charge initially with a paid version, which has more features. So with the free version, you can scan the car using the OBD onboard diagnostic port, and with the mobile app, you can read the state of health. So that's how EV users usually keep a tab of their battery degradation over a period of time. I heard that even for BYD vehicles, there are other applications which can help you to read. Even I'm interested in exploring that more. Maybe in time to come, I will do that with friends EVs. So the state of health of the battery gives you an indication of how good the battery is. So over a period of time, it degrades. And manufacturers usually decide one more parameter. I will explain it at the end of this slide. One more parameter one more measurement that you need to understand is depth of discharge. Now, what is depth of discharge? If you fill the glass with water fully, and if you take away 50% of the water, your depth of discharge is 50%. And if you do the same thing and discharge 60%, your depth of discharge is 60%. And if you fully discharge, your depth of discharge is 100%. Some manufacturers even specify to ensure battery health what should be your maximum depth of discharge. Now, that depends on the technology also. In lead acid batteries, the manufacturers say your depth of discharge should not be more than 50%. That means if you buy a lead acid battery of let's say 70 ampere hours, you should not be discharging it to a level less than 35 ampere hours. Because your maximum depth of discharge should be maintained within that period to ensure longer life of the battery. So similarly, other battery cell manufacturers also quote, like, in order to ensure the health of the battery, you should limit your depth of discharge to this value. Some data sheets might have it, some might not. It all depends. And again, but manufacturers specify an end of life for the battery. Usually, they will assume 70 to 80% state of health, and they quote the number of cycles up to the point where you reach 70 to 80%. Now, this is an important thing to understand. When they quote the cycle values, although I didn't initially explain this when I explained this cycle count, because you need to understand SOH before you understand that. When you put them together, manufacturers quote the cycle count to say your battery will reach, until your battery will reach 80% SOH, you can discharge 500 cycles. Put it that way. Does that mean that 80% SOH from the manufacturer says it's end of life, but will it be really end of life? No. For your EV, it will be end of life probably, because your range will get limited now beyond this point. But you can repurpose these batteries in other industries like solar industry, and like even for Nissan Leaf, they use extensively. They use old Nissan Leaf batteries in solar industry to have a battery backup for your solar system, and also they repurpose the battery modules in electric scooters, electric bikes, even some small electric cars which came with lead acid batteries. Now, there was a Chinese brand of EVs, about 10 cars came to Sri Lanka at that time, very cheap. They were running on lead acid batteries. So some young engineers, they built a battery for those vehicles using repurposed Nissan Leaf battery cell modules. So, and they were running happily with Leaf battery modules, and they got rid of the lead acid battery. So things like this can happen, and the batteries have a further life for repurposing. And of course, at that point, at the end of that, there needs to be a proper method to recycle. Now, that is also a growing concern in Sri Lanka, which we should be looking at and making policies now so that it won't happen in 10 years' time that we have no means to dispose the used batteries. So we learned about battery cycle count, state of charge, state of health, and depth of discharge. And let's try to apply this into some more in-depth knowledge about batteries. Now, typically, a lithium-ion battery will have what we call a charge-discharge curve like this. The voltage versus charge capacity, SOC. When you are charging, the voltage rises, and there's a certain period where the voltage doesn't rise that much, and beyond that, it will rise fast again and reach its maximum point. Now, when you discharge also, the initial 20% or so, the voltage will drop rapidly, and then it doesn't become perfect flat, but it will become flatter, and towards the end, it will get discharged rapidly. So the best part to operate the battery is really when the voltage level is not varying too much, because then the software can really control the power given to the motor and drive the car very efficiently. Whereas at the edges of this curve, the software will have difficult time estimating because battery capacity estimation is not something that we can do, because if you have a barrel full of water, unless you empty and measure during emptying, you cannot calculate the capacity. No, you need to do some estimation. Even if you employ an electric method to get the depth of the water column and multiply by cross area, whatever, that is an estimation. Same thing with batteries. You cannot just hook up a device and come up with a value saying, oh, this battery has this much capacity. So you need to do some calculation during discharge, how much current is being pulled out, what is the variation of voltage during the time, things like that. So this is the shape of the curve. So let's understand. Now, if we consider the straight line segment, you can see it's a depth of discharge of 50%. That means, now this is the best range for the battery to be operated. For your daily usage, it is good to operate in this range because it is good for the life of the battery. Because beyond this, if you charge and discharge, there can be other thermal reactions and negative impacts on the battery also. But LFP batteries, the manufacturer requests you to charge to 100%. That is due to some other reason also, not necessarily operating in this flat range, because now this range for the NMC lithium-ion batteries, it has a slant higher than the LFP batteries. LFP batteries, it is very straight. That means between two battery percentages, the voltage change is very minimal. So the battery management system has a difficult time estimating to understand where the battery remains. Now, let's say if the straight line is from 80% to 30%, the software needs to decide where it is to give the user a useful measurement of capacity it has remaining and calculate and show him your range is this. You can drive this number of kilometers more. Now, the BMS system has a difficulty in tracking this because the voltage change between two different state of charge levels is very low. So the differences, because these measurements cannot be done very accurately, no, they just vary. So because of that, manufacturers want you to charge your battery to 100% frequently and discharge to about 10 to 20% so that the BMS can keep a tab of the charging current and update its tables. So it needs to statistically determine the range so it can get up-to-date information of the remaining battery capacity, and it can realign and calculation can be more accurate. So that's the reason why most manufacturers want you to charge your LFP batteries to 100% periodically. And on the other hand, like manufacturers like BYD, based on their calculations, they show that even if you abuse the battery more than what NMC battery owners do, our batteries will last longer, which is in fact correct. I mean, so there is a certain truth in it because they have improved the overall cells physical structure and cell behavior, which I am not going to discuss in detail because of the time. We may able to schedule a separate session to discuss about batteries in length. Just to give you an idea, lead acid battery, if you discharge from 80% to 40%, the voltage characteristics is shown here. So there's a big difference in the voltage, whereas lithium ion generally the voltage difference is very small. And there's one more important parameter that I need to quickly explain. It is called C rate or the charge discharge rate. Now we say we quote the battery capacity like this, right? 3.7 volts, 2000 milliampere hours. Now the definition of C rate is the rate at which a battery can be charged or discharged within 1 hour. Now if the capacity is 2000 milliampere hours within 1 hour, what can we charge? Only 2000 milliampere, right? So the current that we use for 1 hour can be 2000 milliampere. This is what we call the C rate. So if it is at 1 C rate, the current is 2000 milliampere, either charging or discharging. If we charge it at half C rate or 0.5 C rate, we can use the battery for 2 hours, of course, depending because the current is lower. If we charge or discharge at 0.1 C, we can use it for 10 hours. Now, scientifically, it has been determined that this C rate has an impact on the battery degradation over a period of time. Now, a 2000 milliampere cell, if we constantly charge and discharge at a higher current at 2C, it will lose its capacity faster. Whereas if we charge discharge at 0.2C, then the battery can last longer. What does it mean for an EV driver? If you accelerate fast, if you are a person who drives the vehicle with strong acceleration, very often you accelerate very fast, you draw higher current. That means your C rate is higher. So then over a period of time, you might find that your battery degrades faster than your friends who is a gentle driver. Same the other way around also. When you are charging, if you charge at very high rate very often, your battery degrades faster. This is the reason. In simple terms, this is why people say you shouldn't be fast charging quite often. You should try to use your AC charger as much as possible. These are the reasons behind different recommendations that you find when people talk into social media, YouTube videos. So these are fundamentals behind why you should be doing that. And the same thing, there are different how the charging rate affects battery temperature. Now, battery temperature is bad for battery. These batteries are not designed to operate at elevated temperatures, or on the other hand, operate at extremely low temperatures. Now, in EV battery packs, there are battery heaters, which means if the car is in a environment where environmental temperature is very low, the battery heater will heat the battery first before you can drive. Or some vehicles automatically they wake up and they heat the battery continuously, in a sense, on and off thing to keep the battery in a healthy state. So this graph shows this SOH, which is an important parameter of battery health, how it can degrade due to temperature. Now, in Sri Lanka, we have ambient temperature, average temperature is high. So performance of EV batteries in our country is not good compared to countries, the European countries, where the average temperature is lesser than ours. But on the other hand, during winter, their batteries get damaged if they don't leave the car plug into wall socket in extreme temperature so that the battery can run its heaters of the grid. Things like that. So there are a lot more to talk about those things. But basically, temperature and current are the two factors that contribute to battery degradation. Those two things you need to remember. And these are same thing, how the capacity degrades and how the number of cycles degrades, because now I told you that number of cycles is related to SOH as well. So at different temperatures, if you're operating at different temperature ranges, your cycle count also will get lesser and lesser the higher you go. So, so what you need to understand is, as I told you, convert your charging regime into number of hours that you need to spend charging your vehicle. So that way you can ensure a good health in your battery, so you don't abuse the battery. When you want to really use it, yes. Of course, if somebody asks me, is it not good to run the vehicle after full charge? Because when you do a fast charge and full charge, the temperature jumps up. It is really not good. But if you have to reach your destination without wasting time, you might as well do it, right? You bought the EV to use. You cannot be 100% safe all the time. But in your mind, if you have all these things running, then you will be careful. Wherever possible, you take precautions. Other times, now for example, uh, 2 days back I went to Mathura and I had to charge up to 85%, and my battery temperature rose by 2 bars. I got worried until the time I returned. It remained there. So then I left overnight at home, and in the morning it was okay. But what to do? I had to come back also, and I will have the car to be used. So you need to once in a while abuse it, but don't do it continuously. Keep that in mind. It is not good. You know it is not good, but you make a compromise. And also understand what you pay to the charging service provider is what they get billed from CB. There are losses in the charger, and there are losses in the charger in the car or the outside charger, and you might not get the amount you get billed stored in the car battery. That is normal. Some people have this question, oh, my car battery had a capacity of this much. I charge, it pumped this much of electricity, but the car got only this much. Yes, because there's a loss. What you get billed is excluding this loss. So high current, high temperature are not good. And try to keep the operating range of your battery within the ranges I specified, where voltage curves can be maintained flat, and then you will have an enjoyable life with your EV. One more thing before we go. Those who are from CEB, please excuse me. This slide I captured on the 18th, which doesn't really show the characteristics that I wanted to show, because I did a previous presentation with another slide, which was taken in November. Now this one shows that your thermal usage is quite high throughout the day, and we know why. Everybody is talking about that. Let's not talk about it here. So this was the curve on November 20th, 2025. This is before DITFA. So on a healthy period, where hydro was doing a great contribution, your thermal contribution was very low. But during the peak, there are 3 peaks. During the night peak, we consume a lot of thermal power at a higher cost. So electric vehicle users should be conscious about these. Now at noon, this is actually a forecasted solar rooftop. That means 50%. This can be 50% true or 50% not true, depending on the installed capacity. they have plotted a graph showing what would be the contribution that will come from rooftop solar. So during daytime, the usage of hydro as well as thermal, everything is quite low. But during peak time, thermal power is being used more. So this is where the EVs can impact the country's cost of electricity. So we need to be careful to avoid this night peak to charge your vehicle. So that's why I said charge only what you need. Now you can do a reasonable estimation of what is the amount of charge that I need to have in my vehicle to manage the tasks that you plan to do tomorrow. And if you maintain, let's say, that 80%, 30%, 80% rule, if you generally say need only about 30% depth of discharge for your usage, so you do a 50% top up, or rather up to 80% top up, and use only 30%, still you have 50%. Or you can bring it down further. Maybe you can leave it at 40% and top up 30%, and additional 30% every day. So in case of an ad hoc trip, unplanned trip, you will have 10% that you topped up beyond 30%. And then worst case, you can go down, say up to 20% or so. But regularly, you should not be discharging up to that level. That is not good for the battery. And of course, the battery EV manufacturer will still have a reserve capacity of 5 to about 5% of the battery hidden from you. In a sense, it is to protect the battery again. And that capacity you cannot use. So some manufacturers quote the actual capacity and within brackets usable capacity a lower value. Because of that, they use some reserve capacity which they do not release for traction purpose. You cannot use it. So when it reaches that reserve capacity, it just says it's 0 and you need to charge. So what you can do is, there are charging timers in every EV. Different manufacturers have different features for these timers, but this is from BYD Auto 3. So you can set the charging time. Now we cannot say everybody start at 11 sharp. That is also not good. Why? Because at that point, if everybody has timed correctly to start at 11 suddenly there will be a sudden peak coming into the grid. So you should set up a random time after, say, 11, because by about 11, 10:30 is the official cutoff time for the peak period from CB. But if you look at the usage can go beyond 10:30 also. Maybe 11 may be a good time to start your EVs. Now, there is another, now that will help to save the cost for electricity generation as a country. But there's another problem. Maybe if there are any CB engineers or LECO engineers specifically, some of you may know this. Because of this 7 kilowatt hour, 7 kilowatt EVSC and the dynamic load balancer, if a EV user plugs his car during this peak time for charging, his home circuit, home power feeder is going to draw 30 amperes continuously. Why? Even if the home load varies and goes down, since the car is plugged, the dynamic load balancing will increase the car charging level to match the 30 kilowatt level, maximum level. And then LECO, I was told by LECO, an engineer, LECO has figured out this causes the voltage to drop during peak times. Apart from the other demands that are in the grid, now there's an additional demand from the EVs that get plugged on to the grid during this peak time. The voltage drops, that will cause problems for more people, right? If the grid voltage drops. So the EV users need to be educated on this to shift their EV charging in the night to off-peak period. And also, there are plans from CB to offer reduced tariff for charging service providers during the daytime, so that charging rates during daytime will go down. That will encourage more users to charge their vehicle during daytime using commercial charging stations. For example, let's say you go to Keels during daytime, or your wife goes to Keels. Instead of coming home and charging at the night, avoid the night peak altogether. It might be worth considering charging the car while she's shopping in Keels, so that you get a better economy. That way, if you get a better rate. So CB has not published the rates yet, but I also attended a meeting a few months back before Ditwa. So I don't know what is happening now about it. We'll try to get an update. So that is another message that we want to spread among EV users, not only engineers here, but I need your help to spread this message across the EV community. And I will quickly explain the V2X application then in this presentation. Now, there are multiple vehicle to X applications we call. One is the vehicle to load. That means the vehicle's battery can be connected to a load in your home, like your refrigerator, your fans, your electric kettle, your electric cooker, and especially during a power outage, you can use it, or if you go on camping and things like that. I recently saw a nice picture of two BYD vehicles camping in somewhere in a hilltop in Matale. They have an induction cooker and some lamps plugged into one of the vehicles. So they're cooking and having a nice time camping. And you can have a vehicle to home connection, means you can charge the vehicle battery during daytime from some place where they offer cheaper rates. Go home and plug to your home supply and run the night during the peak time from your battery. Now with LFP batteries, even I would do this if I had a vehicle with LFP battery, because LFP batteries have a higher cycle count. So my worry about the battery degradation will be lesser compared to my current EV. And also there are solutions to give power to the grid. And say peak time, if the utility provider can offer a tariff for you to plug the car to the grid and get some money back, so that maybe you can charge somewhere during daytime at a lower rate and sell it back to the grid when the grid needs more electricity. So this is the vehicle to load adapter that comes with, like, I know that for sure BYD vehicles that they come with this standard. The capacity is either 2.3 or 3 kilowatt. Good thing is now during Ditta, I happen to make a comment on a public forum to BYD users to go to areas where electricity supply was not there. Go to a hospital, a clinic, or places like that. Help those people to run their refrigerator at least a couple of hours a day to preserve their medicine stock. And that went to another EV user who is actually a charging service provider also. He owns some charging stations also. And his house didn't have electricity. And he works overseas. He had a Starlink connection, but he has lost contact with his loved ones at home. And luckily, he had a driver who could understand a little bit of technical stuff. And then he got the idea from me that, oh, I have this vehicle to load a adapter. Why cannot I use it? So he pulled a power extension cable from his Starlink connection and plugged this to his vehicle and started the car. And he was able to get his Starlink connection up and re-establish the communication with his family. And then he called me to get more instructions on. We managed to get some lights working. They are through the existing wiring. Of course, that was a kind of a very carefully managed setup with nobody else touching anything to get because they were without power for a couple of days at that time. So this handy device came in to help. So these kind of applications are there. So when you buy an EV, make sure you buy one of these adapters also, and make sure you check whether this facility is available also, because it can be very handy. BYD vehicles by default get this, but I don't know about other vehicle manufacturers, whether they will give it for free. Otherwise, you can buy one. They are readily available in the internet. Now, vehicle to home is slightly different. This is a Nissan solution. So they have a 6 kilowatt vehicle to home device, what is shown in the picture here. This unit is connected to your home, and it can be used for charging as well as supplying to power to your home when there's no grid power. So it is bidirectional. There are different modes so you can operate. So in fact, one person imported one of these units to Sri Lanka, and he was bugging me to buy it. How would I bought it? As I said, if I had a LFP battery EV, I wouldn't be experimenting with this also, because then we can charge the car with solar or some other place where it offers cheaper rates and run your home from the battery. And of course, there are vehicle to grid solutions like that. And so this is kind of a slide that I prepared for a different audience, just to give some numbers, because people worry that there will not be enough power left for you to drive. No, there are some checks that will be done. Some capacity will be left by the software in the car for you to drive the vehicle, and you can do some calculation and figure out how long you can run like that also. And that concludes, and I think it's very long session. We may open up for quick question and answer, and you may send me any questions or any clarification to my email address jaanaka@hotmail.com. And thank you very much for all the people remaining, because I know it's a very long session, but I hope the information was useful. Over to you, Supun, if you are there.
Yeah, thank you, Engineer Janaka. It was quite explanatory session, even it's long. So hope our audience got much
Hello.
detail on EV charging aspects. So, Engineer Janaka, we already got 2 questions. So I'll put one. There's one question from Samita Karunaratna. It's on in some public. Engineer Janaka, can you hear me?
Yeah, you can read it out.
Okay.
Yes.
Okay. So his question is, in some public DC fast chargers in Sri Lanka, it takes several minutes for initialization, handshake authentication for the charger with the car. But for
Yes.
some others, there is no such process. Car start to charge immediately after the plug-in. What is the purpose of this handshake process, and what is the impact of not having this process?
No, handshake will anyway happen. It might, because it all depends. There are a number of checks done in the charger, as well as there are a number of checks done by the car inside the car before charging the session starts. So depending on the software that that particular charging service provider may be using, these delays may be different because it all depends. Because if you have very fast processors in the charger itself, maybe things happen fast, or it may be slower in some other locations. But handshaking will anyway happen. Without handshaking, just nobody will connect direct power to the car. Car will also perform some checks before accepting the power from the charger.
Okay, sure. So the second question is, most of the EV manufacturers give 7 years warranty for their product. Are they give this warranty for the battery as well? And what actually happened to BYD Atto 3? What is this issue of its battery?
What do you mean? What is the issue of the battery?
I think he's referring mainly for this BYD Atto issue which they faced recently on this
You
vehicle.
mean the customs clearance thing?
Exactly. I think some information related to
Yeah,
that.
that will drag this discussion away from our key focus. But what happened was, now electric vehicles, the power train, there's a powertrain capacity. Now, if you have a motor which can do, let's say, 200 kilowatts, it can motor maximum capacity is 200 kilowatts. But when they design the vehicle, they have a power controller, because the whole drivetrain design is motor, battery, and a power controller. Now, the power controller is the one which decides what is the maximum power that this vehicle should give to the user. Now, simply say, the electric vehicle power calculation should be based on, or power decision based will be based on powertrain capacity, not the motor capacity. But what most manufacturers quote as motor capacity is motor. Some people don't even use the word; they use motor, 150 kilowatt. So what it means is the power train capacity. That is the maximum power that the powertrain will give the user. And now what happened was, back in 2016, the for taxing purposes, a new scheme was created for electric vehicles. Now, previously, the taxes applied were based on value, CIF value, and per vehicle, that's a per unit, in a sense, the whole vehicle, some percentage. So if it is a 2 million vehicle, there was a percentage, and the same percentage is applied whether it is 4 million vehicle or whatever. So the different taxes were collected like that. And from my personal point of view, they did a mistake. They did not understand the powertrain concept in electric vehicles, and somebody worded a new tax table saying motor power. Initially, it was motor power, and then somewhere later, they reworded it motor capacity. And so we didn't know what the definition was, but we had our uh, uh, our responses to it also. That this is not a correct way to do it, but things were like that, and we didn't have a good voice as EV Club for ourselves to influence the Ministry of Finance. So they just left this wording as it is. And in the recent event, what BYD would have done, I mean, I'm just assuming. So they had the same 150 kilowatt motor, physical motor, that they sold to other markets, but they limited the power in the powertrain. So because Of course, the taxation-wise, it was more favorable to have a 100 kilowatt power range, so that you pay less tax for the vehicle. The vehicle won't be that expensive. So, and then somebody raised this matter, and then there was a lot of arguments, discussion going on, and the customs decided to not to release these vehicles from the port until there's some settlement. And so the JKH went to courts, and that thing is still going on. But we cannot talk about the court issue anyway. Then they paid some money and released some vehicles, and all these things happen. But whatever said and done, we strongly believe as EV Club also that the taxation methodology needs to properly define the criteria, because all the EV manufacturers globally, they kind of reach this 150 kilowatt point as a sweet point. If you take a sample of many affordable EVs around the world, they hit that range. So having two brackets as 100 kilowatt and 150, and charging a very high tax on the 150 level is not good for the long-term growth of EV population in Sri Lanka. That's for sure. So I don't know when. Collectively, we need to devise a new methodology for taxation for electric vehicles. The current tax tables, we cannot agree. So that is our stance as EV Club. And that's my personal stance as well, which aligns with the EV Club members, senior members. So everybody believes that the taxation should be revised, because the current taxing method is not favorable.
Okay, thank you very much. And as we come to the end of this very informative webinar on Charge Your EV Like a Pro, we discussed more on EV usage and EV charging and all the details. And it's my pleasant duty to deliver the vote of thanks. So first and foremost, I would like to express our sincere gratitude to our resource person, Engineer Janaka Wilamadharma, for delivering an excellent and insightful presentation, and your practical knowledge and real world experience in electric vehicle usage and smart charging have provided us with valuable guidance. And thank you for taking the time to share your experience with us. Thank you very much, sir. And I would like to extend our sincere appreciation to the president of the Institute of Engineers Sri Lanka, Engineer Kosala Tamburadeniya, for his continuous encouragement and support for technical activities that enhance the knowledge of our members and the community. My special thank goes to Chairman of the Electrical, Electronics and Telecommunication Engineering Sectional Committee, Engineer Viraj Mutugala, for his leadership and commitment in organizing meaningful knowledge sharing sessions such as this. I would also like to acknowledge the dedicated organizing team of the EET ESC, whose hard work behind the scenes made this webinar success. Your effort in planning and coordination are greatly appreciated. Our sincere thanks goes to the IESL Secretariat for their valuable administrative and technical support in arranging this event smoothly. Last but not least, I would like to thank all the participants who joined us this evening, and your involvement made this event a very successful one. And we hope that the knowledge gained today will help you make smarter and more efficient use of electric vehicles in your daily lives. So with that, I conclude the word of thanks, and thank you everyone, and have a pleasant evening. Okay.
Thank you and good night.
Good night.